So as I said, we will begin with that context and we'll move forward. So here is the main course content, and I am sure that you have got this handout, and following this lecture I will send you some supplementary material. If you want to get most of this course, right, and I think it's very important for you to be focusing on data science and machine learning because of things that are coming, then definitely follow up the materials that I will be sending over the next 4 or 5 days. I'm planning to keep all the materials available for you to go over easily and accessible. And I have also some extra suggestions which I will do at the end of the class. If you follow that, I assure you that you will have definitely a good sense of how to use data science, machine learning for supply chain and logistic context. So the content that we have created so far in the day one, today we will be talking about, essentially some example problems and some case studies that we will be taking through this whole course. I will just introduce that. In the tomorrow's class, I will talk a lot more about those case studies, give you more insights about these case studies. And today, towards the second half and the third half, we are basically be doing something. We will be talking about the data science and machine learning aspect of it, right? And in today's class, mainly we will focus on data visualization tools and exploratory tools and so forth. Tomorrow, we will start with the machine learning aspect, and we'll mainly focus on, sort of classification and decision tree based, which is a supervised learning techniques. Day 3, which is on Monday, we will talk about machine learning regression or real valued predictions and so forth. And day 4 and day 5 will be basically summarizing all of this day 3, first 3 days work, and using the case study, we will go through a sequence of Python tutorial, and we will show you how to analyze the data that was collected for all the 3 case studies that I'm going to talk about, and that will give you an insight how to use current software tools to process the information and so forth. Okay. So before I go forward, I also want to take a quick poll of how many of you know Python, and it's okay if you don't know Python at all. We will be also covering everything. So we'll be teaching you basics of the Python, and that will help you in running all the notebooks and so forth. But I just want to have a gauge of how many of you know Python. In the chat, you can type if you know Python. First of all, I got a comment that voice is breaking. Is the voice okay? I see no basic level. Okay. Okay, so the second question, how many of you have done any programming before this course? I mean, it doesn't have to be Python, but any, how many of you have just the programming concept like for, while, if and else, and so forth? Okay. Basic loops, okay. Okay, okay. So I see like a lot of you have, the basic knowledge of this. And as long as if you have some background of how to use for loops, while loops, and so forth, picking up a programming is not going to be that difficult. And one of the things that I want to emphasize that if you want to use the power of data science, machine learning, and AI, you need to pick up some of the Python concepts, because this has like all inbuilt libraries and so forth that will help you analyze the vast amount of data. So I think this might be a good exercise, a micro course where you might pick up some concepts in Python too. Even if you don't have, don't worry. We will hand guide you. We have like sort of a teaching assistant. If you have any questions, we will help you go through all the aspects and so forth. So and that is what is going to come in day 4 and day 5. And today, at the end of the lecture, I will also give you some supporting material that I want you to go through, especially if you have not done Python before or if you have not done programming before. I want to send some materials your way. Go through that, and that will help you in maximizing the benefit out of this course and so forth. Okay, so day 4, day 5, and the whole week we will be also helping you with the Python aspect of it. And as you will see, it is tremendously beneficial for you to process a large scale data set and so forth. Okay, so with that, let's talk about the main topic. What we want to do is, when we talk about supply chain, what is a supply chain? It's essentially a network of companies, organizations, people, and activities involved in creation and delivery of a product from the supplier to the customer, right? And so that's what the whole supply chain is, and it covers the spectrum from the creation to delivery, from the supplier to the end customer. And that means you might have like tier 1 supplier, you might have tier 2 supplier, you might have network of people who are supporting this overall infrastructures and so forth. All is that integrated in the supply chain. It encompasses sourcing of the raw material, production, distribution, and the delivery of the final products that you might be selling to your overall customer. And that also is a part of supply chain. And essentially, for you to be very, very efficient in an organization, you require coordination and collaboration between all the stakeholders in this network, so that you can have on demand, and you can have higher customer satisfaction for your product through the supply chain and so forth. So I know that you are from that domain, but I will take a liberty to also talk about a brief history of supply chain management, how it originated. And it turns out, not surprisingly, this is a concept that originated mostly from automotive industry. And a lot of benefit of supply chain was initially the concept, theoretical aspect of it, development aspect of it was developed in the automotive domain. Okay, so first companies in 1900s, right, to really use the power of supply chain was the Ford Motor Company. So when they were making their Model T and black model, there were only 2 models that they were producing in early 1900s. In order to provide that solution to customer, they were the first to integrate every aspect of manufacturing. So they were manufacturing the cars and so forth. So they had their own supplier from mines and so on, and they have parts suppliers and so on. So they were essentially the first to control and basically originate the concept of supply chain in order to deliver the 2 main products. It was not mass customized. It was like essentially 2 models they were building. But as they were trying to scale and trying to build many of those models, they realized that they need to have a tight control over all the supplier base, and that they were the first to basically start thinking about it and start doing important aspect in integration of the supply chain aspect. Okay, now that created an onset, and then different industries pick up the concept of supply chain and so forth. But now, close to 1970s and 80s, Toyota made the second iteration of supply chain, where now instead of having just 1 or 2 model and just focusing on supply chain of that, what happens if you have multiple different models, let's say 10 or 15 different models and so forth, you tend to need a little bit more flexibility in your supply chain. Yeah, the original supply chain concept that was existing before 1970s and 80s did not require you to have a lot of flexibility, because you have a very set product that you want to sell, and you can integrate and you can optimize. But when the issue of flexibility, when you are thinking of making multiple different products simultaneously and selling that to a customer base in the market, you want some more flexibility in overall supply chain. And this was the rigid supply chain, which is the previous model was not working well for Toyota and so forth. So that's what the second round of innovation that was made, where they started different principles and so forth in supply chain, which allowed for including flexibility in manufacturing a set of products simultaneously to deliver to the customers and so forth. That was then the early, like late 90s and early 2000s, that's what I will call the third sort of evolution, main evolution in the paradigm of supply chain, where if you take the BMW that exists here in USA, and Dell, which was mass customizing a lot of different products. And I want to stop and talk about the difference between the Toyota and the BMW USA and Dell example that I have here. If you take what Dell was doing in let's say mid 90s, they created a IT-based solution for offering customized laptops, desktops to customers. And in this case, they were not only focusing on delivering like 10 or 15 products, but the type of customizations that you can do in order to deliver a product to a customer belongs to 1,000 different varieties of products. So you can customize the hard disk, you can customize the screen, you can customize different aspect of it, and that lead to basically what is known as the concept of mass customization, and that required them to innovate on the basic things that was developed prior to them. And they leverage the power of IT, they leverage the power, a little bit of data also, in order to systemize the supply chain that was required for them to deliver products to the customers and so on. So Dell was one of those companies which was well known for using IT technologies and so forth to bringing their supply chain together in order for issues to deal with the mass customization aspect of the product and so forth. Now, let me also talk about what BMW USA does, because I'm very aware of what their context is. I will give you some insights about them. Okay, it turns out BMW USA is one of the manufacturers. So it's a manufacturing plant. It's the only manufacturing plant of BMW in USA, and it's, as I said, it's located just 3 kilometers away from my office. And they use this plant not only to manufacture cars, which they do, and I will talk about some of the attributes of them, and they sell that in US, but it turns out that BMW manufactured cars here are also cars that are manufactured, assembled, and then shipped to India and China. And all the BMWs that you see in India and China that customers are buying are essentially manufactured very close to my office. Okay, and they have done an excellent job in basically also throwing up a lot of variety. Nowadays, unlike 1990s, the product variety in BMW is like different series. You have hybrids, you have electric vehicles and so forth. Each of them has multiple different attachments. You can get them into customized different ways, different seats, different colors and so forth. So it's also an onset of this mass customization that needs to be dealt with, which BMW does very well with local supply chain. So it has developed this tremendous and effective supply chain that it is one of the remarkable companies in US which is focused on manufacturing everything in US. Typically, US, a lot of things will be manufactured outside, mostly in China and other places and so forth, and they will be bringing in. But this one is an this outlier where the things are manufactured here and sold here. That's great, but they are also manufacturing here and selling it to China and India, where typically the goods are coming from, right? And the reason why they have been able to do is they have been able to create a very well managed supply chain locally. When they came here, they developed all the supplier bases and so forth, and 85% of the parts that or the suppliers that BMW uses belongs in the 200 miles from the factory itself. Okay, so within the local vicinity, and they have also created this whole ecosystem. Remaining 10% of the supply chain and the parts that they do is sourced also by neighboring South American countries like Mexico, Brazil, and Argentina, and so forth. And then remaining 5% is what is coming from China and India. Very, very specific parts are coming from China and India. And using this mix of different suppliers at different locations and so forth, they have been able to deal with this integrate mass variety aspect and optimize that and produce that car, assemble that car in US, and still generate a lot of profit, and in fact go back and sell those cars in India and China. And that's a remarkable thing. So the summary with BMW US and Dell, that onset after 1998, 1985 till 2005 and so forth, there was this era of mass customization that also pushed some innovation in supply chain management, and most of that innovation was focused on integrating IT aspect of it, managing things differently, and dealing with the case of mass customization. And that means that we're having a lot of flexibility and managing different things and so forth. Okay. Now, let's talk about the current generation and what is going on, right, with the things that Apple and other things are doing. So after 2005, the iPhone and iPod and other things that came, and the challenge there is, you are creating completely new products that for which you have to have a established supply chain, and you have to solve those problems. And most of the products that you're creating nowadays, you do not know what is going to be the demand and so forth, right? So demand forecasting is a big problem, and the challenges is like the demands are very, very uncertain. So you might have a high demand immediately after the success of the product, or if the product fails, you might have done too much with your inventory, and you have done too much, taken too many risks, and you take a lot of loss and so forth, right? So there is this era beyond 2005 where the innovation pace is very, very rapid, and things are coming out very, very fast, and the demands are very, very uncertain for high technology products and so forth. And in that setting, that led to the fourth era, a sort of a fourth major push in the domain of supply chain. So Apple and Amazon, and we will be talking about Amazon a little bit further too, that they needed, to customize. They were selling, but they had a supplier base who are selling on them. They need to synchronize, they need to deliver, and so forth. So all of these companies like Apple, Amazon, and other companies, new companies, they started pushing this era of using what is going to be the focus of this class, which is the data science and machine learning techniques to optimize their supply chain. So currently, a lot of companies are basically focusing on using data visualization, machine learning techniques to deal with large-scale problems that they are using inside their supply chain management to optimize their overall supply chain networks and so forth. So that's the current era that we are here. And going forward, I see the uses of data science, machine learning, and AI a lot in the space of supply chain management, and that is going to be a huge space. People have just started in the last 5 to 7 years, but now this is going to percolate through all different industries. And now with the onset and also popularity of the data science and machine learning techniques, we are now going to be seeing the infusion of the use of these techniques in majority of the industry going forward. Okay, so that sets the stage why we need to be talking about, why need to be thinking about data science, machine learning, and AI. And if you have not heard the use of data science, machine learning, and AI, I can assure you that going forward next to 5 to 7 years, anyone who is not using effectively data science, machine learning, and AI, they are going to be not optimizing their supply chain, and that could lead to their bottom line, right? So everyone will be using this class of techniques going forward to optimize supply chain and so forth. Okay. So that's the brief history of how we are setting. So I classified them in 4 major stages, right? The early 1900s, 1970s and 80s, 1995 to 2005, and then 2005 and onward, there is a completely different way of thinking about this. And the current generation is mainly focused on data science and machine learning and their uses. And people have found the innovative uses, and that has really helped them in optimizing their supply chain. Okay, so let's move on. So what is one area that is related to what we will be talking, is supply chain analytics, but what we will be doing is a lot more than analytics, okay? But let me talk about what this area is so that we have the context, and this is what is like the somewhat related, but we will be moving beyond this area in this micro course. So when we talk about, supply chain analytics, it's essentially the process of collecting, analyzing, and using data to increase or improve the efficiency and effectiveness of the overall supply chain management operations that we have. And this supply chain analytics helps you in analyzing the flow of goods, services, and information among all the nodes in your overall supply chain networks. When you're using supply chain analytics, what you will be able to do, you will be able to identify the areas that needs optimization or improvement. And that's the main purpose so far, for the supply chain analytics. And this is where I want to talk about maybe the first portion of the course where we are focusing on, data visualization and data analytics that will help you in finding these areas that you can improve upon in your company or in your setting and so forth. But we will also go beyond that, and we will also see and have a tool set which is based upon machine learning techniques that will help us in how to actually take data and implement the optimization and improvement. Not only identifying, but actually doing something and actually finding effective tools to optimize and improve the supply chain and so forth. And finally, the main goal or the aim of the supply chain analytics is to increase the profitability of the company, and second one is to improve the customer satisfaction and so on. Okay. So again, the three, and what we want to do is, if you take all the main goals, there are three main goals of any analytics or data science based approach, right? We should be able to increase the supply chain visibility, which means when we are collecting the data, using the data, we should be able to visually comprehend and visually understand and have a better story about what is actually happening in our supply chain and so forth. Right? Not just data, but actually having a visibility about and having an actionable information based upon that data is one of the core concept of or main goals of doing the supply chain analysis. The second goal is managing volatility. Okay. Now this is persistent, right? You definitely want to do demand forecasting, how much demand is going to be there for your product. That will help you in basically managing your inventory. Now, inventory is broken down into, if you might have cases of stock out, or you might have excess if you have not done proper planning. So how do you minimize the chances of stock out or excess, and how do you maintain this volatility and so forth, is a very, very big aspect in supply chain management, and that's where the analytics and machine learning techniques could be very, very useful, where it can give you the tools, computational tools, that will help you in managing the volatility that you have. Finally, the third main goal is reduction in the fluctuation in the overall cost. Now, if you have any product or service, is always composed of two main components. One is the fixed cost, which is not dependent upon the number of units, and that is the cost that you have to invest irrespective of whether you sell one unit or not. And then you have a variable cost that is probably dependent upon the number of units and so forth, right? And your job as a manager, or as a person who is managing the supply chain network, is to comprehensively look at the fixed cost and the variable cost, and they will be varying depending upon how much demand and how much inventory that you have. They are never fixed, and this variable cost specifically will be varying. So how do you take into account the variability that can happen in this variable cost and look comprehensively at this combined cost so that you can reduce the overall fluctuation in the cost, is also one of the main goals on supply chain. If you're able to do that, you will be able to hit your bottom line and increase the profitability of your companies and so forth. So those are the three main high-level goals of any analytics or machine learning types of algorithm that we have. And then what I call is essentially the three pillars of supply chain. Okay. So if you want to do something good in your organization with supply chain, then you need to be always looking into these three main pillars. One is the demand forecasting, and you need to be having fairly accurate demands for your product. If you're not able to do that well, you are not going to be able to do very well with respect to the optimization of the overall supply chain that is out there, right? So what we are doing in this demand forecasting, this is essentially a process of estimating the future demand of a product or a service, and it essentially involves analyzing historical data, market trends, and other factors to predict future demands. That's the whole goal, and this is one of the main pillars of supply chain that is there, and we need to be able to use the data science and machine learning to help this aspect, and that is what we are going to be focusing in this course. Okay. The second pillar is about inventory management, right? And inventory management is the process of overseeing and controlling the flow of goods and materials in and out of the company itself, and it involves optimizing the inventory levels and so forth, right? So that's the second important area, or the second pillar of the supply chain. If you're able to do a really good inventory management, right, you will be on time, the customers will be satisfied, and it will always lead to more profitability. And that's what I call the second pillar, or second most important pillar of the supply chain. And finally, the third pillar is the transportation management, right? And it is the process of planning, coordinating, and optimizing the movements of goods and materials from one location to another location in the supply chain through different modalities of transportation, which might be trucks, which might be trains, which might be ships, and so on. And how do I take into account all the different modality of transportation from one location to another location in my whole supply chain and consistently optimize that, is the third pillar that we need to be thinking about. If you're doing that, we are basically solving some important. And in all of these three areas, demand forecasting, inventory management, and transportation management, right? Amazon uses machining in all of this for all their product, at least in US, and they have been innovator in using data science and machine learning techniques, and this is one of the reasons behind their profitability. They have been able to use the data science and machine learning techniques to do these three things really, really well, right? And that's there. On top of not only these three things which I call the pillar, Amazon has also used the process data science and machine learning techniques for managing suppliers, how to select suppliers, how to order them, how to coordinate different things. They have used data science and machine learning techniques there. They have used the customer feedback, right? They get a lot of feedback in text. They get a lot of feedback nowadays also in video, because I don't know how many of you have seen or not, at least in US, there is a Amazon Live service, which basically people are taking products and they are, they're analyzing the products and they're talking to other people how they're using this and so forth. So there is a huge amount of video data also with the Amazon, using the Amazon Live services that they're analyzing to basically understand feedback and improve and provide that feedback to their suppliers or the other places. A lot of products are actually branded, white labeled by Amazon and so forth. So they are using their own data to improve the product that they are selling as their own brand and so forth. And for that, they are using a lot of data science and machine learning techniques. Finally, estimating the delivery time estimate, right? Amazon is one of the companies which is like very, very punctual with respect to delivery and so forth, and they have developed this credibility among the customers that they're very punctual, right? So estimating the delivery time, they are using machine learning and AI techniques in order for us to provide customers with these updated estimates and so forth, right? So not only in demand forecasting, inventory management, and transportation management, you can use the data science, machine learning, and AI techniques, but you can also use for managing your suppliers, analyzing your customer feedback, and estimating the delivery times to a customer. You can use the tools that I'm going to be talking about in this overall class, right? So the focus of this micro course is going to be on learning the tools, the hammers, the drills, and so forth. If you think about those as a tool to fix something, we will be giving you the data science, data exploration, machine learning tools that could be used to deal with and fix the issues that you can see in the aforementioned areas that is there. Okay. So with that, let's move on and let's talk about and introduce the three main case studies that we will be carrying out through this course, which will help in understanding some of this aspect that we have mentioned in this slide, and we'll pick some of this aspect in this slide and see how we can address those concerns using the case studies and using the data science, machine learning, and AI tools that we will be learning in the class itself. Okay. So with that, before I go on and discuss the case studies, what I want to do is I want to, talk about or take any questions that you might have. Any questions? Okay, I see none so far, but if you have questions, just let me know. Okay, so let's move on. And what I'm going to do is I'm going to cover some of this case study and give you some context a little bit more in tomorrow's class too. But let me begin so that you can get a context of what we are going to be doing and what are going to be the main problems that we are going to be studying in this course, and how the data science, machine learning, and AI could be used in this settings and so forth. Okay. So we have a case study for a Freshmart, and this I have changed intentionally the name of this company. This is a company that provided some data to us, which we analyzed locally here. Okay, and this is about grocery store. So grocery industry is a highly competitive industry with very, very small profit margin. So in order for you to realize that profit margin, you have to have a very high operational efficiency, and you need reduce cost, and that is the key in this competitive market. There are 100 different brands in US that are competing with each other, and I'm pretty sure this is the same case in India also, that there is an onset of multiple different brands who are opening their own new grocery stores and so forth. And we also have competition from the normal you know the modality of street vendors and so forth, right? So how do you win this grocery games where you are in this fierce competition is one of the case studies that we will be dealing with in this overall micro course, and that will be the motivating examples, and we have a data set, and we will analyze and create tools and use the techniques that we learn in this class to process that data set. So what are the challenges that a grocery store face? First of all, they have to maintain a steady supply chain. If you are not able to maintain a steady supply chain, their operational efficiency is going to reduce, and that is going to lead to their loss in profit and so forth. They have to ensure the quality and the freshness of the products are high, because if the freshness is not there, customers are not going to buy, or they are not going to be repeat customers and so forth. So they have to ensure that. They have to be very tight on managing their inventory level. They cannot have a high inventory or low inventory because the space is tight. And if they have a high inventory, then maybe they need more refrigeration that adds to the overall cost of the grocery stores and so on. And then finally, they have to be able to meet the customer demand in a timely manner, and they don't want to be out of stock for certain, with respect to the certain grocery when the customer is coming on. Okay, and now we will show you through the use of data science, machine learning, that how the FreshMart was able to optimize their supply chain operation to essentially deal with some of the challenges that we are mentioning here. And that will be the first case study that we'll be using throughout this micro lesson course. And yep. The second case study is focused on transportation, and the third one is also focused on transportation. The second will be focusing on shipping. Okay, and now shipping industry plays a vital role in the supply chain management for businesses. It is used for transportation of goods, it is used for logistics, and it helps with overall inventory management and so forth and so on, right? So how can we take this complex process of shipping and so forth and simplify that process? Using data science and machine learning is the second case study that we will be focusing on this course. Okay? And if we can do this, what are the challenges we are going to be dealing with? For example, if you take the shipping operation, they face challenges in multiple different dimensions. They are always focused in reduction and reducing the transportation cost, their fuel costs, so they have to optimize their route. They have to solve for different logistic issues and so forth. They need to focus on minimizing the delivery times and so forth and so on, right? And there are multiple different issues that they always come up with. For example, if you see the recent ongoing war between Russia and Ukraine, right? That has led to disruption in shipping routes and so forth, right? So people have now altered the shipping routes, and in that setting, in this disruption, how do you minimize the transportation cost? How do you deliver on time? Is a big issue that a supply chain management has to deal when they're dealing with the shipping transportation system. Okay. They are also concerned with monitoring the shipping performance in real time, so they want to see how much cost, how much fuel, how my inventory is spread across the oceans and so forth, and identifying bottlenecks in the inventory management with this real-time, management of the ship is one of the key things that is evolving in this generation. And these are some of the things the shipping operations face. And we will see, which is belonging to the third category of the supply chain management, which is the transportation management. We will see how data science and machine learning can help businesses gain insight into their shipping processes and identify areas of improvement that they can work on, and that will help them in basically dealing with some of the challenges that we have listed here. Third case study that we will be talking about is the truck delivery systems, and people have now been innovative and have been able to place a lot of sensors and collect very useful information from there. So how to use some of the data collection techniques and so forth in trucking industry, and using the tools that we will be learning in this class, which is the data visualization, machine learning and so forth, to solve the pain points of the trucking industry is the third case study that we will be focusing on. Okay. So trucking industry plays a critical component in the global supply chain, and it facilitates the transportation of goods and products from manufacturers to retailers and consumers. That's the main goal. And trucking is like, omnipresent in any supply chain that is out there. Doesn't matter whether it's US, India, China. Everyone uses the trucking industry as the main modality of transportation and so forth. So what are the challenges the trucking industries face, and how does it affect the overall supply chain? So first, they are focused on route optimization. So the delivery route, if they can optimize, they can save cost and fuel, they can minimize the overall time to delivery and so forth, and that helps in efficiency of the supply chain. They're focused on minimizing the overall fuel consumption, because that's the main cost for the transportation. If you can minimize the cost of the fuel, then they will be able to deal with lower cost, and then that will lead to increased profitability. Minimizing idling time. So if they have a cohort of trucks or a group or an ensemble of trucks, they do not want them to be waiting or being idle. So managing the overall fleet and minimizing the overall idle time across the whole fleet of trucks or vehicles that a company might have is also an important problem, and that way they can minimize their fixed cost, which is purchasing the number of the vehicles that is belonging to their fleet and so forth, right? And this is a big area where people are using data science, machine learning, and AI techniques. And finally, increasing the operational efficiency, how different things are moving across the trucks and so forth, is another area in supply chain management where data science, machine learning techniques are playing key role, and that will be the third case study that we'll be focusing on during this overall course that we have. Okay, so this is the overall context that I wanted to talk about. So we will be mainly dealing with the supply chain issues, and we will be taking these three main case studies as motivating examples going forward. And what we will do in the next class, a follow-up class, and today later on we will learn the tools, which is the data science, machine learning techniques and so forth. We will use these tools in these three case studies, and that will ground the knowledge that you have, that you will gain from this course. So what we'll do now is, I know that this is a 3-hour long class, so I wanted to do split this in 350 minutes. So what we'll do is we will take a 10-minute break, and we will come back in the 10 minutes, and we will restart with a new topic which is focused on data visualization going forward, and that will be the second portion. So we will take 10 minutes break, and then we'll come back and